to take a lot of pictures, and the computer will then produce the 3D model. That's something, if this is like more interesting to see on the computer when all the data are put into the software. What's foreseen there is then how we generate this 3D model, and then this 3D model is like point clouds, so it means a lot of points for every tile, everything, and then you can make a decent drawing, a decent 3D model that you have to abstract anyhow, because it's way too many informations that you get from the point cloud to be useful. It's great, you know, you can see every tile, how high, what's the shape, where it's cracked. You can count all the tiles that you normally cannot, but it doesn't give you answers for anything. So if you design, it's too much information. You have to abstract it like you do it with the measure. So in, I don't know, modern buildings, it's kind of makes less sense because it's not so much information. In these heritage buildings, it's nice because we will have all the details. We will be on the model. But that's what happens in the computer. We will do a presentation of that, probably on the Zoom. You are all invited, sometimes like some months after. That is probably more interesting. But today it's like basically a boring process. It's a process of taking a lot of pictures, because the pictures are what gets into the computer. Photogrammetry means making the model from the pictures. The alternative way is we can do it laser scanning. It's slightly different. The laser has the advantage that it knows the exact distance, I don't know, from me to the every point. And it can be more precise in that way. However, the laser has less stand points. So usually when you put the laser, you put it to a station, and then the machine goes with the laser with a lot of points from one point, and then you move it from another point, another stand point. And you have a lot of dead ends, because you cannot make so many stand points that with the photography, you see like all kind of the dead points will be made from the laser. And photogrammetry is another. It's cheaper, it's simpler, because you can make it with the telephone if you want to. And the lasers are still quite expensive. This will change in next, I don't know, 5 years probably. But for now, it's still, you know, the good ones are like, I don't know, 50,000 euros or something. And the good photos is, I don't know, a couple thousand euros, and you can even make it with the bad photo. The number of points, the resolution is important. You know, we have on the telephones, we have like information, like 50 million points, which you don't know what to do normally, because it's too much. But for the photogrammetry, the resolution is important, because more points means bigger precision. And bigger precision means that you can throw away the points that are not good, and you still have enough points to do calculations. So as many pixels are welcome as possible. It does mean on the other side a lot of calculation for the computer. But actually it doesn't matter if the computer works on a model for 1 hour or for half a day. You just set it, and then overnight he can calculate it. So that doesn't matter that much. How to take the pictures? The first rule is that all pictures have to be from the different standpoint. So, you know, you cannot make like the pictures, but you have to make a pictures and you have to move. Because that's the way the trigonometry, basically the photogrammetry is an old science, so to say. They say Michelangelo knew how to do it. It was done, I don't know, 50 years ago for the mapping, mostly in the mapping industry. So if you know the distance from the standpoint to different points, you can calculate with the triangulation the distance from the points. However, it's a long process, it takes a lot of calculation. That's why the photography became useful in last years, when we have computers that are strong enough that they can calculate all this in decent time. It could have been done, I don't know, 10 years ago. It has been done, but it took longer than today. And of course, the digital cameras with high resolution make this useful. Because the resolution, I don't know, we have 10 years ago on digital cameras was maybe not enough for the photogrammetry. So it's actually a tool that is like cheap and easy to do these days. Maybe it was 10 years ago or 5 years ago. It's nothing special today. Probably in the future, okay, you have some phone that has also a LiDAR laser scan, like just one beam. But when this will be combined, then it will be really great, because we'll have the exact, it will be much more precise. The precision nowadays is actually very high, but you still have to put the information to the computer how big the church is, whether this is like a Barbie church or this is a monster church. So we will show you, I will put the labels, the targets are called, which is something that we will measure. So how precise we will measure from one target to another target. The scale, yes. To scale the model will basically be telling us how precise the measurement is. So, but usually with the measure, there's 1 centimeter error very easily. So, but even if you measure it with the hand, it's the same error. Even maybe sometimes don't admit it, but we are not between the 1 centimeter accuracy usually, especially with this kind of objects that are all out of the angle. And, so of course, sometimes the errors can add up. So you have 1 centimeter in one room and 1 centimeter error in another room. And sometimes at the beginning this can be as much as this. But normally it's between millimeters accuracy. Especially now if you measure like how high is this? It's like between millimeters, but you don't know where to take the measure. Here, here, here. And so it's not so much error, but you are not sure where to measure it. This is also so for today, to stop with the philosophy, the targets are called these labels I'm putting in. I have started from the inside. I will put some of them from the outside. There are two reasons why we do with these targets. One is, as I was saying before, we'll measure it by hand or with other scanners or with the normal meter, the distances. So we can scale the model to the exact size, and on the other side to control it. That we know some measure we won't put into the computer just to check it if it is what we expected, so that the errors are not big. And the other thing where we use the targets is we calculate, we don't put all the pictures together in the computer at one time. Because computer he compares every pictures with every other picture. So if we have, I don't know, we have 1,000 or 2,000 pictures for this building, it's much simpler for the computer if we calculate like just one room at one time, and another room, it's called chunks, and the outside is another calculation. And then we have to assemble, like say, from the inside. Here probably inside and the roof will be another chunk, and the outside will be another chunk. We have to put these models, that will be like 3 models, we have to put it together. And the targets will be at the doors and at the windows. It's really great if we have windows, because we can see, normally if there will be some light from the outside, the target can be seen from the inner side and from the outer side as well. So we can say, okay, computer, this is the same spot, align it. And when we'll be the outside, we'll have to do the target as well. We have to put some light inside. So maybe we can go inside to see just the targets.